In this video, I'm going to show you how to go about solving trigonometric equations. So that generally means finding the value or values of an angle when given a particular ratio. So first let's just go back and look at our what the trig equations mean and where they are in terms of the Cartesian plane. Okay, so we've got our quadrants 1, 2, 3, 4. Alright, and if you remember when we had our unit circle, we know that the y values, if we've got something up here, y value, we know that's sine. We know that so y is sine. We know that the x values are the cos values. X values there are cos values. And remembering that when we had tan, we extended it out and then measured the height up here from wherever the tangent was. So the unit circle goes around here. If the angle went up to here, this was your tan. So that's tan theta there. Okay, now obviously we've got positives and negatives of all of these. So you can use this little acronym CAST. Starting in the fourth quadrant, C-A-S-T, and that tells you which ratios are positive in each quadrant. So A stands for all, so that means they're all positive here. So any angle between 0 and 90 or 0 and pi on 2, the sine, cos or tan of any of those angles will be positive. Okay, positive x value there, positive y value, positive tan. Okay, when we come over to here, we're still on the positive side for the y-axis. Okay, we're still positive for a y value, but we're now negative for the x value, and we're also negative for tan, because remember we extend it down this way, and that becomes negative. So this is sine positive here. Over on this side, this is tan positive. Okay, extends up there, tan positive, but sine and cos are negative. And over here, this is cos positive, and the others are negative. So all in first quadrant, only sine in second, only tan in third, and only cos in fourth. So that gives you some idea of what your value should be depending on what your ratio is, whether it's positive or negative. So if you remember that, that's a really good start. So let's have a quick look at a couple of examples, just going through those. So if you consider the angle 330, remember we measure it from here, there's 0, so 330 is way all the way around there. Okay, we want to know whether each of the following are positive or negative. So sine of 330, so we use our cast, we know this is C A S T. Okay, so sine, well, we're over here in the fourth quadrant, sine is going to be negative. Okay, so sine of 330 will be negative. Cos of 330, it's going to be positive. It's positive x value, positive. Okay, and tan is going to be negative because it's extended down here, measured as a negative value from the x-axis. So that will be negative there. Okay, so you can see there's our cos value, there's our sine value, that's negative, and then tan is extended down as well. Okay, so negative, positive, negative, using the CAST. Now for the angle 210, okay, so we started off over here at 0 again, we've gone round to 210, using cast, CAST. Alright, so tan is going to be positive, and all the others are going to be negative. So we can straight away say that's positive, that's negative, and that's going to be negative. And you can check these with your calculator. Now, the nifty trick here is that you can just use whatever the equivalent acute angle is. So although this is 210 all the way around here, we know that that's 30 degrees greater than 180. So if you're using your exact values for 30 degrees, you can just use the exact value and then determine whether it's going to be positive or negative because you know it's in that third quadrant. Okay, so when we're solving trig equations, what we're trying to do is find the value of the angle. Find the value or values, okay? There's often more than one of the angle, okay? You should always have an idea, or approximate idea, of what the answer will be. So this is where your sketching comes in handy. Alright, so sketch your unit circle, and put your values on it, and that'll give you a good start. It's for the idea of what your answer should be. So you want to consider the quadrants where your solution is going to be located, solution or solutions. You want to find the equivalent acute angle, and then state the angles in the given domain. And this is important because this determines how many solutions you need to give and whether they're going to be in degrees or radians. So this will make a little bit more sense when I show you an example. So we jump in here. Okay, so without the assistance of a calculator, solve sine x is negative root 3 on 2 for x between 0 and 360 degrees. Okay, so the first thing this tells me is answer in degrees, not radians. Okay, good to know. The next thing we've got over here is the negative here. Alright, so if we do a little sketch, okay, it's going to be somewhere like this, where this value here is root 3 on 2, negative root 3 on 2. Alright, so I should be able to see straight away that my answers should be going from here, it should be greater than 180, and then between 180 and 360. So these are my two answers there. So what you're looking at is if we draw a little spiral, start around here, where does it cross those two? Okay, we've got one there, one solution there, and one solution there. Okay, so we know from our exact values that root 3 on 2, sine of theta is root 3 on 2, then theta equals 60. Okay, so that's from our exact values. So that means that these angles in here, I might draw this a bit bigger. Okay, so we've got this like this, got like that there. We know that that's going to be 60, and that's going to be 60 degrees there and there. Okay, and I know it's negative because of this negative here. So that means it's going to be on this side of the x-axis. Okay, but the domain given was between 0 and 360 degrees, so I can't just say it's 60 degrees because that doesn't make sense. What we've got to consider is that we started over here at 0, and we've gone through 90, through 180, okay, around 270. Alright, so my solutions are obviously going to be starting here, 180 plus 60, that's my first one, okay, and then you can either look at 180 plus going all the way around here, or you can do 360, take 60 to get that one there. Okay, so theta is going to be 180 plus 60, which is 240, and also 300 degrees. Okay, because your second solution comes all the way around there. Like that. So there are your two solutions in the given domain. Now for a different domain, if they said between 0 and 180, for example, there would be no solutions. Okay, if it said between 0 and 720, there'd be 4 solutions. So this is really important that you pay attention to what the domain is. So you're looking at going around, finding out how many times, if you trace through that domain, how many times do you cross your lines to get your solutions. Okay, let's have a look at another example. So now we're looking at tan is 1 over root 3. Okay, we know that that means that the angle we're looking at is 30, because we know tan 30 is 1 on root 3. 1 on root 3. Okay, but again, we've got a negative. This is important, so if we sketch it like this, this is going to be going this way. Oops, should go through the origin. Sorry, that's a terrible drawing. Okay, where that's 30 and that's 30 there. Alright, so that's what we're, there's the angles we're considering in here, 30 and 30. Alright, and I know it's that way because it's tan, goes straight through, because I know that tan of 130 is 1 on root 3. Okay, now the domain here given is 0 and 2 pi, so the 2 pi tells me that I'm now in radians and I need to answer in radians. Okay, so 30 is equivalent to pi on 6. Right, so that's what we want to start thinking about. We've got 2 pi over here for a full rotation, and this is pi over this side. Okay, so the angles that we're looking for, and it should be x that we're solving for, x equals. So if this is pi, and we want to go back pi on 6, so it's like we're going back 1/6. So that's going to take us to 5 pi on 6. Okay, and same over this side, this is 2 pi. Okay, that's the same as 12 pi on 6. If we take off pi on 6, that's going to take us back to 11 pi on 6. So it's kind of just like fractions to work out these two here. Okay, so our two solutions there, 5 pi on 6 and 11 pi on 6, and that's because when we trace around here, we hit 1 once there, that's one solution, come around, there's another solution there, so we cross that line twice. Okay, so really that's all there is to solving trig equations. If they do get a little bit more complicated, all you're looking for is to get to the point where you have something like this, Okay, so sometimes you might have a tan x plus 1 equals, something over here, and you might need to do a little bit of rearranging. But ultimately what you want is sine cos or tan of your unknown equals some ratio or some number there that you can then take the inverse tan of, or inverse ratio of, to get a value, your equivalent acute value for that angle, and then you sketch a unit circle and work it out that way. So using the equivalent acute angle to determine the value of the ratio, okay, you might need to rearrange the equation first. Consider the CAST acronym to determine whether it's going to be positive or negative. So this is where your sketching comes in handy. Okay, sketch. I know I say this a lot, but it really makes your life a lot easier if you draw diagrams. So if you're given a negative cos value, for example, you know that that's going to be over here somewhere. Okay, that's negative cos. Alright, so just get used to sketching those and it'll just make your life so much easier. Be aware of the domain. Okay, the number of solutions required is dependent on it. So you might get sometimes up to 720 or even bigger, depending on how the examiner's feeling. You might have to keep listing solutions. So make sure that you get them all, otherwise you will end up missing out on marks. Okay, the domain will also tell you whether to answer in degrees or radians. If the domain is in terms of pi, that means radians. If it's not, and it has degrees, that means you need to answer in degrees.